let's look at how to write out the solution to a problem using a technique that reinforces all the best practices of physics problem solving. So getting in the habit of solving problems in this way is really important for becoming better at physics. So as we look at this example problem, which has to do with accelerated motion, it tells us that there's a soccer player running at 1.5 meters per second east, and that player accelerates at 1.2 meters per second squared in the east direction for 2.0 seconds. What is the velocity at the end of 2.0 seconds? So we have lots of things going on here, and the first thing we need to do always is write down, sort of unpack and write down the information we're given. So we'll start out with some given information. The first thing we're given is the velocity of this soccer player, and it's a velocity because it has both a magnitude, a speed, and a direction. So we'll write it as a vector, and since it's given at sort of the beginning of the situation, not at the beginning of the sentence, but it says that the soccer player is running 1.5 meters per second east and then does something, we'll call this V1, velocity 1. And this velocity is 1.5 meters per second, and since we just acknowledged that it's a vector, we need to give it a direction, not east or west, but positive or negative. So in order to do that, we have to define by convention, and by convention, defining means to just write a little picture of a graph and say that positive x is this direction, and that's east, and so that means that, for example, negative x direction, west, would be to the left. So we've defined that positive is to the right, is east, and so we can, even though we don't need to, we can write positive 1.5 meters per second there. We've also been given an acceleration, and we're told that that acceleration is 1.2 meters per second squared. Okay, and we're also told that the acceleration occurs in the east direction as well. So east, by our definition, by convention, is positive. So we have a positive velocity and a positive acceleration, which means that this soccer player is speeding up, since those vectors, velocity and acceleration, both point in the same direction. We've also been given a change in time, delta t, at the end of 2.0 seconds implies that the clock starts counting at 0 seconds and goes for 2 seconds. So let's consider that delta t, oops, not 0.2, but 2.0 seconds. And what we're asked to find is the velocity at the end of this time of 2.0 seconds. So we're going to call that v2, and we don't know it, but we're asked to find it. So you could say that that's not one of the givens, of course, but that's what we're being asked to find. So we have this soccer player who is speeding up in the east direction as he runs east. And let's just go ahead now and begin, after we've written down our givens, begin by finding some equation or some idea that we can use to help us here. So let's start with the definition of acceleration. Acceleration is the change in velocity over the change in time. And by definition, change in velocity means v2 minus v1. So we have what we need in disguise here. We simply now need to do some algebra. So what we're going to do is rewrite the definition of acceleration. We're just going to kind of unpack it or expand it, however you want to say that. v2 minus v1 over delta t. And we now have what we need to find. We need to find v2. We have v2 in our equation. The problem is that our equation is now solved for acceleration, and we could put all these numbers in and compute it, but that is really kind of a I don't know, junior varsity way of doing things. The most varsity or most mature way of attacking this problem at this point is to use some algebra and solve for the variable that we're interested in. So we're going to do some algebra. Well, if I multiply both sides of this equation by delta t, then I will have isolated the numerator of the fraction. So I'll write delta t times acceleration is equal to v2 minus v1. And I'm about one step away from having this equation solved for the variable I'm interested in, v2. And I can get it there by adding v1 to both sides. So I'll say delta t times acceleration plus v1 is equal to v2. And I now have that equation solved for the variable that I need. Now, if I wanted to, I could sort of neaten it up and write it in a more standard form where this variable that I'm interested in is on the left-hand side. So I'll go ahead and do that. I'll write it over here. All right, v2 is equal to, I'll change this around and say a delta t plus v1. The multiplication is implied there. All right, now and only now do I sub in the values I've been given. If I sub them in before, it just becomes a big mess. I might not have been given neat, tidy numbers like this. I might have been given numbers with many digits, and then it takes forever to type it in on the calculator over and over again. So we always want to solve the equation that we're using for the variable that we're looking for, as we've done here. So now I'll go ahead and sub in v2 is equal to, for acceleration, I've been given positive 1.2 meters per second squared, and it's going to be multiplied by delta t, so by 2.0 seconds, and to that we're going to add v1, which is positive 1.5 meters per second. Okay, now what we need to do is acknowledge, or at least look for and figure out significant digits, and because we're going to be getting an answer in a moment, so let's just check 2 sig digs, 2 sig digs, 2 sig digs. So right over here, maybe in the margin, I'll make a note that there are 2 significant digits. It's supposed to be an S. Okay, now the next thing I want to point out is that when we talk about following the units in physics, that means that when we cancel, we're expecting to find units consistent with the measurement that we're looking for. So this is a velocity that we're solving for. So if I go ahead and multiply meters per second squared times seconds, what cancels? This seconds cancels out the seconds squared, and I end up with meters per second. So when I do this bit of arithmetic here, 1.2 times 2.0, I'll get 2.4, but the units, notice, are meters per second. That second has canceled, so meters per second plus 1.5 meters per second, and these now work like variables. I can add meters per second to meters per second, and I end up with 3.9 meters per second. So in following the units, they are consistent with what I'm solving for, which is a velocity. That's a further check on my technique, on sort of confirming that I'm on the right track. So this final velocity, v2, we've computed to be 3.9 meters per second. Now we're not done until we write a therefore statement, and we also acknowledge the direction, because we have said from the outset that this is a vector, a velocity vector. So therefore, the soccer player, let's get this problem showing back up again, at the end of 2 seconds, the player's velocity is 3.9 east, and since this is a direction, I'll put it in brackets like that. Okay, so we've got definition, the convention for our direction, our reference frame, all of our given information, and then the information we're looking to solve for. We have our equation that we're using, which began with the definition of acceleration, which we then solved. We sort of expanded it out and then solved for the variable that we were interested in. Over here we rewrote it in the more kind of typical form, We made a note of significant digits. And when we subbed in the values, notice that we subbed them in completely and always with all of the units so that we can follow the units as we cancel and use that as a further confirmation that we're on the right track. We got a mathematical answer, and finally we expressed the answer in a sort of almost like a narrative where we told what the meaning, the physical meaning of the answer stood for. And that is how we solve problems in the most varsity, if you will, varsity way in honors physics.